Find all rational zeros. 1 0 has been given. The way to look on your test actually is 1 0 will be given, and they'll give you some numbers down below, and they'll ask which number below is also a 0. So there's actually a couple ways of doing that, but your start has to be exactly the same. Exactly the same. The way you're going to, no matter what, start this thing out is, so if 5 is a 0, you want to know what remains once you run that 5 through. So we're going to run some synthetic division or substitution here again. And so 5 is a 0. It comes from the factor x minus 5. The 0 is what we run through as our multiplier. Oh, gosh. What am I doing? Just use your coefficients, right, folks? Hello, 1, negative 11, 38, and negative 40. There was no terms missing, so we don't have to put a 0 in anywhere. Sorry about that. Drop your 1 down. Multiply. Add. Multiply. Add. Multiply. You get a 0 out, which you should. If you don't get a 0 out, you made a mistake somewhere. Because they're telling you that when you put 5 into this function, when x is 5, you get a 0 out. So that's not a surprise. In fact, if it's not, again, you made a goof somewhere. But what that does now tell us is when we factor out the factor of x minus 5, when we divide this function right here by x minus 5, what remains is 1x squared minus 6x plus 8. In fact, off to the side, this stuff is really, it can be abstract for a lot of students. What might be good right now is to pause and just check out that if you take the yellow highlighted function, x minus 5, and multiply it by the blue polynomial, it equals the green one. Just remember that was kind of a foundation of this synthetic stuff. Like this machine right here that I'm about to highlight, this machine in here seems really weird, but it truly does divide out these polynomials when we do it correctly. And you can check dividing, just like when you divide plain old numbers. 8 divided by 2 is 4. I can check that by taking 4, the answer to division, multiplying it by 2, and I get 8. Take the yellow times the blue, and you get green. Anywho, so math teacher just got excited about all this stuff. I apologize. So back to the task at hand. Which number below is a 0? Well, this isn't set up as multiple choice. But go ahead and find both the zeros, because there are 2 more, right? Because if our degree is 2, it means there's 2 more zeros coming from this remaining polynomial. Let's try to factor it. Can we factor that trinomial numbers that multiply to 8 and add to negative 6? That'd be negative 4 and negative 2. So this thing factors to x minus 4 times x minus 2. And so what makes this blue remaining trinomial equal 0? Well, positive 4 and positive 2. So x equals 4, x equals 2. So for multiple choice, either 4 or 2 should be in the list down below, and whichever one is down below, you would check, because that is a 0. Bada bing, bada boom. Let's try, I don't have enough space for, I could probably squeeze in 42. Let's go for that. So from here, starting over again on 42, this is our 0, so that's going to be our multiplier. Put your coefficients into synthetic division. There we are. Drop it down, multiply. And again, it said this produces a 0, so you better get a 0 out. But why we do that is because now we know that when we divide this polynomial in green by the factor of x plus 2, which running negative through 2 through is the same as dividing by x plus 2, we realize that our remaining polynomial is 1x squared minus 6x plus 5. Now, this is a quadratic, or a degree 2 trinomial, folks, so you can use the quadratic formula, but if you can factor that thing instead, go for it. Numbers that multiply to 5 and add to negative 6. Negative 1. Uh-oh. Maybe this one's not factorable. I feel like I'm just not awake yet this morning. Oh, yeah. Negative 1 and negative 5. Oh, boy. Oh, boy. So, we can factor that trinomial as x minus 1 times x minus 5. So then, as 0 is actually x equals positive 1, and the other root or solution is x equals positive 5. So, 1 or 5 would be down below, and that would be your solution. I don't think there's any, like, from here, I don't think they get drastically tougher. So, I'm going to do this one and call it. So, we're running 2 through. Drop the 1 down, multiply, multiply, multiply. Again, we get a 0 out, which we should. So this is our constant, this is our x term, and this is our x squared term. So really, we have x squared minus 16. Now, if you're like, oh, I gotta factor that, looks scary. You know, we're trying to, another way to write this is x squared plus 0x minus 16. We have 0 x's, as you actually see right there. So we're trying to multiply to negative 16 and add to 0. Well, if we add to 0, it means the two numbers need to be exact opposites. So positive 4 and negative 4 multiply to negative 16, but they add to 0. Maybe you realize this was difference of squares, and you can just add and subtract this. Add and subtract the square root in here. There we are. So anyway, that's the factored form, folks. There's a couple ways to think through it. You can either use the diamond method or your shortcut. So x equals negative 4 is a solution, and x equals positive 4 is the solution.